hello from Romania, from our favorite artist electronist, Mr. Q12. Alright, what I have here is a little bit different from the last time we met. I have this LDRs, light dependent resistors, it means. You see this 3 here, another 4 there, you see? And it's working fine, but I had some problems, of course. These are the LDRs, and this is the setup. This is the setup that I did also in reality with 1 kilo. Basically, I made a voltage divider, I think it's called, right? And when this is changing, here is exactly like a potentiometer. When this resistor is changing by depending on the light intensity, it will change the voltage here in the middle, and this voltage will go to a input pin as before. But this time I linked everything, every available input, so all of them. All 8 of them, I linked them. And this is what I'm having here. Here I'm having actually 7, I think, not 3. No, I have 8. I have 8 of them. Yeah, 4, 5, and another 3 here is equal to 8. So I did actually some tests. Oh, here I don't have, in the simulation I don't have 8. I have this variable resistor that I will, it's easier, it's faster here in the simulator to do it. You see, if I'm moving the mouse like this, it will change. But here, it doesn't have this functionality with the mouse. Even the mouse is changing, I cannot drag. I only have to press these buttons, horrible buttons, and well, it is changing but very slowly, and I don't like it. But here I can use it on the fly, pretty much. So I let only one potentiometer here, but basically is exactly what I'm having here, is mimicking what I'm having here. So that's the difference from what I have, the setup I'm having. I leave here this potentiometer for convenient, to be extremely convenient. It is very convenient for me to use it like this. So you get the point. Other things, I put some LEDs. This LED is also in reality. This circuit that you are seeing here is exactly as I'm having it right now in reality, with minor differences. This potentiometer here is only for convenience to actually test very quickly here in simulator, but in reality is an LDR and 1 kilo there in place of this. Here is the 10 air. Probably I changed it from the last time. I had some problems, and that's why I had to insert these 3 LEDs here on the other lines to actually see exactly what I'm getting. They are these 3 LEDs that you are seeing here. These are the output LEDs that you are seeing there, and are these guys here. As you see that I modified a little bit. I took out the resistors that were on top here for each, because this is not in reality. This is how it's looking in reality, what I'm having there on the breadboard, with the 10 kilo for all of them. And it's exactly what I'm having here. That's the 10 kilo there. And every one is linked, you see, with a metallic link, and that yellow link as well. So they are common, having a common link, everything, and passing through 10 kilo resistor. That's it. And exactly as I built it in reality, I made a replica here, and it's working. It's working absolutely fine, as it is here. So let's play it a little bit. Let's see it working. Oh, of course. I have to add the file. I leave it. You see, this is the last time I had the last file included here. This number I have to change it. But to change it, I don't have it here in the temp file. So I will have to go here in the test, open my actual test file in Arduino. Let's wait a little bit. I have to run it, to compile it, verify it, or whatever it's called, to actually create this folder. When in the moment I clicked here in this folder, it created this. It updated the folder with. I have all this junk here. Usually this file, this temporary file, as you can see here, this temp file is filling up to 5 giga, up to 10 giga, 15 giga even. So only the automatic cleaners like CC cleaner or Windows cleaners, they are accessing this folder, and they are clean it automatically for you when you have some settings there. But me personally, I like to do it manually, as I'm doing here. So pretty much what I'm doing, I'm pressing Control A, which you mean this, it means I'm selecting everything pretty much, and then press delete. Where are you? Delete here. Press delete. This is popping up. Do you really want to delete all these files and directories? Yes, motherfucker. All, everything. Skip all that you cannot change. Of course, this file got erased. The important thing that I want. So no problem. I will compile it again. Error. Yeah, when I'm doing this, it's throwing me an error. Let's see. No, it's not. Let's do it again. No. Okay, no problem. I close it. I'm opening it again, and now when I'm pressing it, it remains stuck something in the memory. And when I'm clicking here, it will update here. You see, and the folder is available. Now I can copy the number here from the build, and everything is clean. That's what I did here. And I'm changing this number here like that, and pressing OK, and now it should run correctly. So when I'm pressing this, this is actually reading the values that I'm having here, not the stuff that I'm having in reality here, because they are working in parallel. And the file that I'm using it here in Proteus for this Arduino, that hex file, let me stop it to actually show it. So this file, test.ino, you see, test.ino.hex, this hex file is actually used both here in the simulator and by the real Arduino here. It is used. It's loaded. Pretty much the Arduino is reading that file and is loading it inside its memory, both here in the simulation and in reality. Okay, so right now, come on. So right now, these values that you're seeing here are actually the values that I set up, and everything is different a little bit. You see, this is 8, this is 12. That's why I'm having a little bit of difference. You see, this. Let me pause it. So this is 08, this is 12, and this is the 08 value from there. But it's not really the 8 in binary. It's something that is coming through the division of the voltage here that is computed. You know, it's a calculation there. It's not really the exact. You get the point. You know. You don't have to expect the exact binary value that you are setting, especially here in the simulator, because you can see exactly what you are doing, but in reality it's chaos, you know. And this one is 12, or let's say this one is 16. I arbitrarily put some random values to everything, and this is 35, this is 40 pretty much, and this is very easy to variate. Yeah, this is 40 as well. I should, where are you? 40, 60, like that. I should make it like that, because the last two are, yeah, probably those two, I don't know. They should have been, but they are not, because it's not actually the percentage that I'm having here and here. It's or the value. It's actually the calculation between this and this, and also from this point and this point. And it's a little bit. That's why I'm having different stuff values there. So all right. So this is the simulation that works absolutely fine in simulator, and it is working. And this helped me quite a lot. And also I changed the code a little bit from how it was before in the beginning. I'm not sure. Yeah, I made this pin 14 on A0. So the A0 you see here, and where are you? Here is the A0. You see this pin this is starting from 0 at 13, and then it's continuing here as 0. Actually, this is 14, 15, 16, 17, 18, and 19, pretty much. This is but they call it A0. I put a wire here from A0 like this. I put a wire to here, and to this wire as well, not linked to this here, or it wasn't linked there, to this alias. So now I deleted. I only showed you what test I did here. So I did this test by linking this pin, and I made the code. I commanded that pin directly from this from the code. I commanded it. Let's see where I put it. If I'm having it anymore. No, I don't think I'm having it anymore. I only leave that as a reminder on the top. Somewhere here it was in the int0 function that I'm using it for the interrupt. The tests that I did before, I completely forget to link this alias to the clock. So I was having it, let me open a preview to it. So this is how it was. This is how it remained on the breadboard, like this. You see this alias, where it was linked to this 1 kilo to the positive, and then I took out this entire circuit, I replaced it, but this alias pin remained with 1 kilo to the positive, and it remained like that just to have it activated, and it worked like that, but with some errors, and I couldn't figure it out for quite some time why it's giving me the errors. But especially when I was changing the addresses, that's the problem, you know. But by itself, if you are restarting the circuit and you are changing one value on a single address, on only one address, like I had it here, and like I had it in reality for quite some time, I had only one potentiometer that I changed it on address 0, and everything, all the addresses, I didn't play with the addresses pretty much. Where are you? So I didn't play with the addresses. I leave it on set up on address 0, and that's it. And everything worked like this in this configuration, you know, with this 1 kilo on the alias pin. So in certain circumstances, it's working absolutely fine like this. If you don't play with the addresses, pretty much. But if you start to play with the addresses, this is not good anymore. This configuration that I'm having here is not good anymore. And I looked back, I checked back this earlier circuit that I'm having here to see what I was making before that was working in comparison with what I was having here. And that was the only thing that actually remained like this here. And I remembered, yeah, I had to actually press and include this alias into the clocking. Doesn't matter from where it's getting the clock. If it's getting the clock from reality, in this case, this is the clock that I'm linking to that pin directly, exactly directly as you can see it here, or to a manual button if I want to switch it to a manual button, doesn't matter, or from code like I showed you, or from here from code. I only leave this as a reminder that I did it. I didn't leave the actual code that was changing, but pretty much what I did, I inserted it here in the front of this increment addresses. So here it was in the front, and it was changing that pin A0 or pin 14. It was toggling. It was toggling to 0 and to positive, and then resetting it somewhere else back to 0. And here it was setting it 1, and somewhere else it was setting it 0 when all this if was terminated. Probably in the end of it, it was setting it to 0. And then when it was coming again, the function was called again. It was set to 1 to positive, and it was performing all this stuff inside until it was reset to 0 again, and so on and so forth. But by doing it in reality, by linking it in reality, I cleaned the code a little bit. So for me, in my case, it matters what I'm doing in reality with what I'm doing in the code. If I want a clean code, I make a more complicated circuit in reality a little bit, or vice versa. If I want a clean circuit in reality, I will make a more complicated code, you know, in Arduino here. So that's the difference between these two things that I did. So this was a major problem that I had, and I couldn't figure it out for quite some time until I looked back on the previous circuit and figured it out that I had to switch to toggle this alias pin as you can see. I completely forget it. I leave it as a problem to resolve later. That was the thought at some point in all my tests that I did. So that's a mistake in some way, but also I had to update to adapt the new. This is the new code that I had to adapt it also in hardware. Is all that I'm trying to say. Okay, so you get it. So this is a reminder that I put here. LDR pin 22. This is the pin. LDR pin 22, as you can see there. Linked directly to clock, exactly how I'm having it right now, or to Arduino A0 pin 14, but you have to make it in code. So you have these two options. This is the reminder that I put here. 10R is there for protection for IC overheating. I don't think I included this before, but now I did update this circuit with this 10R here. For some reason, if that VREF is linked directly to 0 volts, the IC will overheat. In my cases, in the case of my ADCs that I'm having, this 0808 that I purchased 10 of them from AliExpress, and I got screwed up with them. They are already used, visible already used, and I'm not very sure. I already complained about it, and I already told them that I want my money back pretty much, and I didn't get any answer from them. It doesn't look like I will get any money from them. Well, I will see, but I'm very, very disappointed that I got them used, and nobody was mentioning it, and it is a screw. They screwed me at this point, because if they were mentioning they are used, I was thinking double before buying. You know, I didn't have this knowledge of them being already used when I buy them. So that's problem. But as problematic as they are still working with this 10 resistor here, which this is a little bit of solution, is limiting the resolution a little bit of it doesn't read perfectly right now with this resistor. And if I'm increasing this resistor here, it will limit even further the resolution of the ADC. It will work less good. Very badly it will work if as much as I'm increasing this resistor here. So I have to be very, 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 very careful with the value that I'm using here. But for now, until now, nothing overheated. Everything is working absolutely perfectly. I discussed this problem with my friend in England, that he made it work. He made it work. His ADC with ADC0816 he is having a little bit different from mine that I'm having here, and it worked with his absolutely fine with that. This 10 ohms resistor is working directly to the negative rail, and nothing is overheating. He is actually using the oscilloscope. He is probing everything, and he's showing me some results. And I believe him, of course, because trust is important when you are doing experiments with some other person in parallel. And what he is saying, I do believe him. And it shouldn't work. It shouldn't overheat pretty much. That's the conclusion. It shouldn't overheat. But if it does overheating, then you can use this little trick that I discovered here with this 10 ohm resistor. So that's it for this part. I discussed and explained everything to that. Here in reality, let's play this in reality and see how it's working everything. And let me close this. That's the old. And let me open. So here I will have to open serial monitor. Here. All right. So now I am reading actually the values from reality. Let me. I'm not sure. Yeah. The first value I believe is fucked up. And let me pause it when it's okay, good. So let's see, this is a double, because this is how it's starting. This probably it's only this monitor that is inserting a double value there, but after that is absolutely okay. So these are the actual values that you are seeing here, and try to remember this one, the first one and the second one. Okay, it's 0011 and then 0001. You know, you see this is almost equal. These three are almost equal. And now and it's the same for everything, I believe. Now I will leave it running, and I will do this. I will change the intensity of the light. I will include some shadows. Although those LEDs are reflecting the light from my skin, probably. Let me pause it. And if it was, let's see, on the top here, if it was 0011, before, let's see, here, you see, it's 001. And yeah, you see, it's different. It's a little bit different as it was before. And this is, let's see, on the top here, 0010, all the ones. And here on the bottom, it's kind of the same. And I don't see the difference, probably for that one. But let's see the last one, 01000. Nope, still the same, motherfucker. But I'm telling you, something did change, but it's not really. I will do it again because. Okay, so I'll have to do it like that. And if I will cover, these three, I believe it's 1, 2, 3. Yes, I will cover them. So when I'm putting my hand here over this tree and I'm shadowing them, look on this tree, the line. So where is the line? The first three of them, if you can catch. So now I'm putting my hand over them, and let's see how it's changed. You see, 0011. No, it's exactly as it was before, and now it's a little bit of change. Now I'm shadowing them. Yeah, you see, the second one it did this time. This one it got 000100, but here you see it's 0011, and the rest. So it definitely changed. They are changing, but there are so many, and the difference is not. Probably this is the last. Yeah, this is the last. Yeah. No, I did scroll up a little bit, and to see the difference between the two. So the third one, it's quite the same. This one is quite the same. Yeah, here you see is 00. At some point it was 1011. You see there, here the third one is 11011, but here is 00110. And here you see how many 111, the third one I'm reading only. So they are definitely changing. But in this format, when you see it in this format, it's not really obvious in what they are changing. You kind of skip it, you know, your brain is skipping it, but they are changing. So these values are actually read. The program is actually reading every value that I'm having here, depending on the intensity that I'm putting, the light intensity or the shadow intensity pretty much. And it's changing all these values for each. So one line of binary value that I'm having there. So line 1 and line 2, line 1 represents the intensity of one LDR that I'm having here. So let's see actually here. Yeah, here is so it's here. This is input 0. This one. So this is the first line. The value of this first line is the intensity in binary from this LDR, the first one on input 0. On input 1 is this second line here, and is the value of the light intensity of this LDR, which is the second one. You see, first one, second one, and is on this pin here because the chip is facing in that direction, and I have to kind of read it inverse a little bit. And this is input 2, which is right in the margin here. So it's that is the margin, and is here. You see, this is the third one, the third LDR, and is the third line here. And this is the value of the intensity of the light or the shadow, intensity of the shadow, or intensity of the light of that LDR that I'm having there. So that will further in the code. Right now the code is only reading and showing me all these values at this point in time. I'm not doing anything, I'm only reading them. And I was able to do it. It wasn't hard. Actually, it wasn't hard at all, because this increment address that I'm having here, that I already tested it in Proteo Simulator, this already worked absolutely fine without any kind of problems. I didn't have to change anything inside it. Yeah. I only changed this. I added this when it's for convenience only. When it's starting the first line, the first line when it's starting it, to add this line here. I believe this is the first line. It's only for my convenience to actually see when one block is finishing and one reading of the block is starting, pretty much. I call this a block of readings. When all the addresses pretty much is cycling through all the addresses and is reading at each address is reading all these bits and of the ADC, and it is functioning. It is functional. I most probably should put this entire line here after the last line. Well, I do make mistakes, but for some reason I didn't see this a problem, a big problem. So I leave it as it is right now. I was thinking on other problems, more important problems, when I put it here. But now I see that it's kind of wrong after this line. I was having an error on the last one. Yeah, definitely that line is not good here. Definitely this line is not good here. What the fuck? Yeah, the change is minor and doesn't really matter. 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 of them, which is good. And now let's auto scroll. And if I'm moving my hand over there, like that, let's see. Now I get my hand off. And now I'm putting my hand over it. Alright, thank you very much for watching, and see you later when I will actually do something interesting with it, I hope. Yeah, we will see. Thank you very much from Romania, from your favorite artist electronist, Mr. Q12. Bye bye.